Hello, geometers. I hope this video finds you all well and your family doing well. Maybe except for boredom from this whole situation, but hopefully you're dealing with that okay. Something constructive and creative, maybe helping out with the whole need for personal protective equipment for our medical people. But whatever you're doing, I hope you're all well. And I hope you haven't had any trouble with homework from Tuesday. If you do, be sure that you contact me, email me, and I'll get back with you as soon as I can and answer your questions about that and help you through it. If you're falling behind, I'm going to be in contact with you at the beginning of next week and with home to make sure that you don't fall behind, you stay caught up, okay? Because we can't let you fall into a pit on this one. We want you to succeed. So we're going to talk today about section 2, which is about triangles and special cases. Now, yesterday we talked about radicals, and the reason we did that was because when you talk about triangles, you don't want to be rounding things off, and radicals are actually very precise. If you get your calculator out and you do the square root of 2, it's going to give you this long, actually infinitely long decimal value, 1.21, blah, 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 whatever. If you try to type that into MathXL or try to do a problem with it, that's not precise. That's not exact. And when MathXL gives you a problem, you know how they are. They say, give an exact answer. So we don't want you to round that off to a decimal and do it on your calculator. We want you to express it in terms of radical 3, radical 2, radical 5, whatever it is. Leave the square root there. Don't do it on your calculator and simplify it. So we're going to talk first of all about this. This is probably a review ancient history for you, Pythagorean theorem. If you have a right triangle, you know that it has a 90-degree angle in it. All the angles in the triangle add up to 180. So if we tell you the side of the triangle, say is 2, and this side is 3, then you can use the Pythagorean theorem and figure out the hypotenuse by saying, okay, 2 squared plus 3 squared, that's 4 plus 9, that's 13. That's the hypotenuse squared. Be careful of that. So the actual length of the hypotenuse is the square root of 13. I can't simplify that because it's prime. So the hypotenuse is radical 13. Don't call it 13. That's a really, really common mistake. So be careful of that because the hypotenuse is actually the square root of the sum of the sides squared. So it's a squared plus b squared, then take the square root to get the length of the hypotenuse. So we don't have to use the Pythagorean theorem for everything. So we have these special triangles. And the first one is a 45, 45, 90 triangle. That's the measure of all the angles. So if you know one of these angles is 90, you know the other one's 45, you know that 180 minus 90 minus 45 leaves you with 45. That's probably going to come up on the homework. You're going to have to do that. So remember that one first of all. And it turns out that if you have one of these isosceles triangles, remember that? Two sides congruent, the third side not. Scalenes where none of them are, and equilateral is they're all congruent. So if we have this triangle, we have one of the sides is 1, the other side is 1, then the hypotenuse is, by the Pythagorean theorem, square root of 2. But that's a pattern to all of these because no matter what the length of this side is, just call it x, the other side has to be the same, and the hypotenuse is that side length times the square root of 2. And you don't multiply that out with the calculator. You just call it, let's say the side is 5. The other side has to be 5, and then the hypotenuse is 5 radical 2. If we tell you the hypotenuse is 10 radical 2, then this side is 10, and so is the other side. They're congruent. Now, MathXL is not going to give you a problem like this with a decimal value, like 10.2, whatever. I'm not going to do it. They're just going to have it in terms of a radical, and you have to figure out what the other two sides are. Follow that pattern, you'll be great. Now, if they tell you that this side is 20, then you actually have to divide that by the square root of 2 to get the other side. So it's 20 over radical 2, and this would be 20 over radical 2. But I don't think MathXL does that to you on any of the problems. If it does, contact me and we'll figure out how to do it together. Now, the other special triangle is a 30, 60, 90 triangle. Again, look at the angles. 90 degrees here, 30 degrees and 60 degrees. Here's the pattern on this one. You have a short side, you have a longer side, you have the hypotenuse, the longest side. So it's A, 2A, and a radical 3. I don't really like how they wrote that as radical 3a. I understand. I don't like it because when we write answers, we don't write square root of 2, 7. It's 7 radical 2 because that way there's no confusion. We always put the radical after the whole number portion. It's just how it's done. So remember the pattern on this one. If this side's 5, then the hypotenuse is 10, and this side is 5 radical 3. You're done. If we tell you this side is 2 radical 3, then the shortest side here is 2, and this side is 4. You're done. That's the pattern. And if you know the angle, you know the other side is 90 minus that angle. That's how you find that other angle. That's really the MathXL lesson in a nutshell. Okay, remember, if you have any trouble with this, send me an email. I'll answer your questions as quickly as possible. I've gotten a lot of emails since Tuesday, mainly from my other classes, not from you guys, but please don't fall behind on MathXL and shoot your questions out to me and have a great weekend. Please stay safe.